Okay, I'm looking at Lab 5 in DC, and this is a circuit simulator here that we can use to build some of the circuits that you have to build. So when I go here to Lab 5, there it is, and I have to build this first circuit here, which is just a voltage, a series circuit, I should say, and it's a 1K, a 2.2, and a 3.3. And so I'm going to go back to the simulator and first show you how I got to it. And it defaults back to whatever it comes up with. But if you go to falstad.com and go /circuit, if you'll just Google Falstad, in fact, I'll do that for you. Google Falstad circuit. It will be here, and you can just click the full screen version if you want to get straight to it. So I've got a DC source already in here, which I'm going to need for my lab. And I'm going to get rid of a couple of these things that are there. I'm going to move this DC source to the other side, and I'm going to show you how to add these things if they're not there. So we need a resistor down here. We need to get rid of the switch, and I'm right-clicking on these things. So what I got to do is I got to right-click anywhere on the black part and do Add Resistor. Come down. You'll see now I've got basically what I had. Whoops. And see, I did an add resistor there because I was still in add resistor. So I'm going to right click. I'm going to delete it. And I'm going to come up here and do an add wire instead of add resistor. So now I've got 3 resistors and I've got a source here, but they're not any of those the right value. So we're going to go back and look at this lab, and you'll have to pardon me. I've got 100,000 windows open here. 1K, 2.2, 3.3, and 10 volts. So let's set that. So I right click on my source and say edit. I'm going to make it 10. Hit apply. Okay. And then I'm going to right click on this and say edit. Now I've got 2 choices. I can type in 1K, or I can type in 1000, which is the value, and notice it changed it to a 1K. So just double checking these things once again. 1K, 2.2, 3.3. 1K, 2.2. So I'm going to edit this guy. Oops, I didn't highlight him. There we go. Edit. 2.2. Don't forget the K, or type in 2200. I'm going to edit this one, and again, I can put in 3300 if I so desire, and it'll change it to a 3.3. Now here's what's nice about this particular one. You can see my circuits moving. I've got a current flowing through as illustrated by these lines, and I can change my simulation speed. I can click anywhere on here, and in the right hand corner of your screen you'll see the voltage is 10 volts. It'll also show you the total resistance. 1K plus 2.2 is 3.2, plus another 3.3 would be 6.5. And I can right click right here and I'll see what voltage is remaining. So I've got a VD of 1.53, VD voltage drop of 3.3 there. So excuse me, this dropped 1.5, this dropped 3.3, and this dropped 5.0. So let's see if Ohm's law holds true here. We know, break out our trusty calculator, and I'll have to bring it onto your screen. So I'll kind of get it where hopefully we can see both, or at least much of it. So 10 divided by 6.5 equals 1.538 milliamps. So let's see if that's what it's showing. And sure enough, anywhere we look, we see I is 1.53. If I get on it, 1.538 milliamps. So right here, I'm showing 10 volts. If I come here, it says my voltage drop is 1.538. Well, that's pretty easy because I can just take this value times 1,000, and that's going to give me 1.53 volts. So that works well. Coming out 2.2K, and it tells me my voltage drop is 3.385. So put this in memory. If I multiply that times 2.2, 3.385 if we're round, and I can do a memory reminder and multiply that times 3.3 and get the 5.07677 that's getting. So the nice thing about this is we can simply hover over things and get our results. Now, occasionally your lab may say, what is the measured value of these components? Well, this is a simulator, so if you put in a 1K, it's going to be dead on 1K. So how would you turn that in? Looking at this lab we're looking at, what you could do is just open a Word document. I'm not asking you to print these from home. I understand you can't print them, but if you'll open this document here, what I would need is the course you're in and the lab number. And what you could do is just do data table 5.1 and put I theory equals I point A equals I point B and I point C to kind of show you that, all you would need to do is come up here, put your name, Lee Radney, ELCR 1010, lab 5, and then right here put data table 5.1 and do I theory, if I type theory correctly, equals, and put that value there, I point A. Or you can write them on a sheet of paper, and if you've got a way to scan them in, there is a little app I used to use on my phone called Tiny Scan, where you can scan these things in. So you can either email me this Word document, make sure it's got your name, make sure it's got your course, make sure you give me the answers, and I can give you credit for those labs that way. So this is going to work real well for DC for most of you. AC has some limitations as far as what Falstad can do above a certain frequency. I'm working on how to handle some of those even as we speak. But pretty neat simulator. I'm going to wipe this out and just make another one from scratch just so you can see that one more time. And just like building on the breadboard, but except we're using the actual values. So I've got just a couple of wires here. Let me get rid of those. So let's just say I wanted to, first thing I want to do is output and sources. I'm going to do add a DC source. Let's see, add voltage source. There it is. There's my voltage source. Get in there. Whoops. See, I'm duplicating things. I can right click and I'll right click on that and say delete. And if I ever need to get out of that, I can hit escape. Now I should be able to drag this. So whatever you select, it's going to keep doing it until you hit escape, and then you can add whatever you want. So let's just say I wanted to add 3 parallel resistors. So I'm going to right click. I'm going to say add resistor, and I'm going to draw one here. Lower it down just a little bit. See, notice I'm adding another one because I can delete it. What I want to do is shorten this guy, but I can get there in a minute. I'll add another. Whoops, I already changed it. Add resistor and add resistor one more time. So there's 3 resistors, and now I want to add wire. Now, if you want to make this pretty, you can. If you realize that it doesn't have to be exactly parallel, you can. As far as the wiring, totally up to you. I'll keep this one kind of cockeyed a little bit, but let's say this is a 20-volt source. I can just simply hit edit, Here, tell it 20 volts. If I have my num lock on, I can 20. Okay, let's say I want this to be a 1K. I want right click on this one and make it 2K. Edit. There we go. 2000, and right click on this one and we'll make it a 3K. If you look, you can see current. Remember, the lower the resistance, the higher the current. So we got more current going through the 1K, less going through the 2, and even less going through the 3. And I can look here. I can come right here. There's my voltage, which is 20 volts. Each one of these is dropping 20 volts because they're in parallel. Now let me just say if I added another resistor pair here and added those in, and we'll keep them 2Ks. Now both of these are seeing 20 volts, but since they're the same value, each one of them is dropping 10 volts, and across both these junctions we get 20. So anyway, you get the idea. I can click anywhere and see the drops. I can click anywhere and see the current, the individual branch currents there. 10 milliamps here, 6 milliamps there, 10 milliamps here, 20 milliamps. So 20 plus 10, that's 30, plus 6, that's 36, plus that's about 46. And here I should be showing about 46. So very intuitive once you get to playing with it. I wanted to get this out to you so you could play with it if you wanted to ahead of time. But for you guys in DC and possibly some in AC, and going to be looking at this for solid state, linear, and digital for those of you in electronics. But some of you that's in DC, this will be what you can do to do your labs, and just give me that Word document. Possibly for some of the lower levels in AC, it's also possible that some of your labs may be just where I do something, explain the concept, and then test you on it. So there's going to be a way to do these labs even online. And all I need to have you do is just send me the answers. You don't have to print out the text, and just work back and forth between the simulator here. And I like the simulator because it's fully online. You don't have to install anything on your computer. So if you have any questions about it, please let me know. But otherwise, I'm going to let you just begin doing this. Now, there's a way to save these things. And if you save one and want to send it to me, I'll give you some extra credit for that, because that could allow me to do some things with it that might help your fellow students there. So totally up to you. But if you do, I'll give you some extra credit for doing that. But when you send me that file, make sure you say ELCR 1010 Lab 5 or whatever it is that you had there. And I realize some of these have you remanipulate the circuits. I'll take whatever you give me as far as whichever one. I can always modify it back. Or if you want to save each section, even better. So this will give you a way to possibly continue some work uninterrupted. And I'll be looking at the more advanced stuff from here, but want to go ahead and take care of the low-hanging fruit. I think the limitations on the AC is something like 4 kilohertz. So in other words, we can't go over 4,000 hertz. So if you have anything in the AC that's less than that, that should work. I'm about to look at some of those in a moment, but wanted to make you aware. Thanks.